Part of the reason why we're struggling is because we're missing a really, really, really important detail to get started. The first thing is, at least from what I saw and what I talked about with Ms. Kowalski, is we don't really know the real first step to solving these equations. What do you think the first step to solving a quadratic equation might be? By the way, we'll consolidate groups when we start working later, so Taj, you might have somebody. That's a decent question. I'm just going to jump to here real quick, okay? When you say which one, what do you mean? Okay, so which form? Guys, I need y'all to hear me on this. What Deshaun is asking is the right first question that it doesn't look like many of us are asking. Because some of us are trying to multiply and distribute and do all these things that we don't need to do. The first question you need to ask every time you look at a quadratic equation is, one, what form do we have? Why is that so important from the beginning? To know what steps to take. Guys, are you going to use the same steps when you have factored form as when you have vertex form? No. You got to know, what form do I have? And it looks like we forgot to pay attention to that detail. What form do I have? Which, by the way, this is why I said that you've got to know your forms of quadratic equations. We talked about that all the way back in, I want to say the beginning of February, maybe middle of February when we first started studying the forms of quadratics. But this is also why I told you if you didn't show proficiency in the last unit, that's okay, but we've got to master these things. Okay? When I look at this number one, what form do we have? And how do we know that this, and I'm just doing the right-hand side, I'm not doing the whole equation, how do I know that this is a factored form? So I see that similarity to x minus r1, x minus r2. Now I will point this out. And so Deshaun, I think this is a little bit of what threw you off. Is this perfectly like x minus r2? No, and that's why we had to learn something new with this, okay? So this is similar to factored form. I need y'all to remember, when we say factors, what do we mean by factors in mathematics? Not x's. No. See, we got to be clear about this. What are the factors of 6? Why are 2 and 3 factors? They are what are? Multiplied. Guys, when we say factors in mathematics, what we are talking about are the things being multiplied. What's happening between every set of values up here? They are being multiplied, right? I got addition, subtraction inside those parentheses, but I got multiplication among all of those things. That is a factored form. You've got to be able to recognize factored form. We'll talk about that in a second. That's why we learned a new strategy. So I'm going to come back to that. I just wanted to be clear. If I have factored form, in general, what concept, so here, factored form, I already have it labeled, factored form, what concept have we learned this unit that allows us to always solve a factored form? It's got 3 words.
Zero product property.
Zero product property. Jordan, I'll be right there. Okay? Zero product property. Zero product property. That's what we need to think. As soon as I see a factored form, I need to think and hope. Jordan, I've got cards right. Where did I put them? I also have your DYU, wherever I put those cards. They were where? Yeah, but then I set down, here they are. Jordan, here you go. Kings. And there's your DYU. Okay. Taj, why don't you go ahead and join the Kings as well, so that we have a full group over there. Alright, so if I see factored form, guys, I need to think the zero product property. Now, if I were you, I might get out my Frere models where I have a consolidation of all my notes into just a few pages. And on the Frere model, that literally says factored form with quadratics. I would ensure that I have it written down, if you have factored form equal to 0, what are you using? Zero product property. Guys, you have a whole, like, not a thick packet, a packet of like 5 to 6 pages. That's it. There's a summary notes for the entire unit. I would get that crap out. I would write it down. I would study it. You gotta learn it. Andrea, I thought you said you were going to try to make sure you don't fall asleep. I know, but I need you to get sheets of paper out so we can make sure we have our crap written down. Jack, same thing. Come on now. Alright, so y'all, remember, y'all have a series of papers. I think it is literally page 1 in there. On that, because I labeled them, I numbered them. So yeah, don't worry about that. Let me see this. Okay? Guys, we got to try to stay organized. I have them numbered in the bottom left-hand corner. So 5, 6, 7, 8. That is 3, 4. There it is. 1, 2. Solving quadratic equations in factored form is the one you want. That's it right there on page 1. Solving quadratic equations in factored form. Okay? You gotta recognize, and if you need to, write out the factored form. Remind yourself of what tells you it's factored form. If we are multiplying factors, it's factored form. Okay? 0, and so we need to keep that in mind right there. And if I have a factored form, I want to use the zero product property. Can't always, but we're going to talk about why we can't always. You didn't get it. I passed out last like Monday or Tuesday. If I got to find some more, I will, but we passed them out last week. Okay. What about if I have vertex form? First off, what is vertex form?
Fx equals a c x minus k h plus k, or squared plus k.
So if you have a binomial, two terms like this, squared, man, that's a vertex form right there. And so what is it in number 2? What's the equation there? So 1, you got to be able to recognize number 2 is what form? The vertex form. Okay? If you have vertex form, what strategy do you want to use?
Find your vertex? Or?
We already have vertex, and we want to graph that vertex, sure, but what strategy do we use if we have a quadratic in vertex form? It's something that half the questions have asked about. Inverses with
Property of equality.
properties of equality. One thing I want to point out to you is, how many times do you see the variable x right here?
One.
You only see it once. It is not the only time, but if I only see my variable one time, that's a guarantee that I want to use inverses with properties of equality. Let me say that one more time. If I only see my variable one time, that's a guarantee that I want to use inverses with properties of equality. You don't see it, Zion? Okay. I'll have to find a copy later to give to you or print it. Hold on. How many pages did I print out through? 10, I think, for y'all?
Yeah.
Y'all good over there? There's always printed out. So, Inverses of properties of equality. Zai, if you want to come up here, it's printing. And so, if I see my variable how many times? Once. You can do it at other points, but if I only see my variable once, that's a guarantee, hey, I want to use inverses with properties of equality. That's something I might write down under the solving quadratics in vertex form. I think that starts on page 5. I could be wrong, it could be page 3, but I'm pretty confident page 5 of your Freire model is where it says solving quadratics in vertex form. Is that right? Yep. Again, a big hint. If I see my variable how many times? Once. I'm probably going to try to solve my quadratic, or solve the equation. Not just a quadratic, but solve my equation using inverses with properties of equality. They're good strategies to use. And then we get to our standard form, which this was not on this demonstrated understanding. But standard form. What is standard form?
X squared plus b x, or plus bx plus c.
That's it?
Plus AX.
Ax squared. Okay. Remember, a is in all of them. And to be honest, you get to a standard form, and you should say, oh crap. Because you know it's the only way you cannot solve a quadratic equation, or what only? Standard form. It's the only one. I need y'all to hear me on that, right? If you have factored form, you might be able to use the zero product property. If you got vertex form, you can use inverses with properties of equality. You got standard form, if you keep it in standard form, it's going to be a rough day in the neighborhood. I don't feel like guessing and checking. But that's why we can factor, that's why we can create vertex form, and you're going to learn one more strategy today. Okay? So, the first question you have to ask is, what form do I have? That form informs you of what strategies you should take. If you do not take the time to say, this is factored form, or this is vertex form, or this is standard form, you don't know where to go from there. Okay? You don't know where to go from there. But number one, what form do you have? Factored form? We all in agreement that that's factored form right there? Yeah? Okay. Well, you don't need to. If it's already in factored form, does it say anything about factoring more up there? No, what does it say we need to try to use? The zero product property. Guys, if it's in factored form, I'm using a zero product property. Now, to use a zero product property, what does that equation have to equal?
0.
Does it? No, but what did the directions say? Find the zeros. First, let's see. Jack, do you remember what another word for zeros is?
Roots.
The roots, right? So why do we also call those roots zeros? And I will say this, there's a slight difference between them. They're not exactly the same.
The y value is 0.
But the y value is 0, right? The idea is that the root values are the same as the zero values, and it's just wherever the y value is
0.
0. Thank you. My output here, my y is 0. So, Mason, remind me, what is the zero product property?
Any, or whatever multiplied by 0 is 0.
Anything multiplied by 0 is 0. So what is the only way to multiply this crap and get 0? What's the only way to multiply this stuff together and get 0?
0 product property.
Yeah. But that means what? One of these
X.
what?
X minus 4 is 0.
Either one of these, what is x minus 4? That is a
Factor.
factor. One of the factors has to equal 0. Notice, Deshaun, can you solve this without factoring that 2 out? You don't know, how many times do you see that variable in there? How many times do you see the variable? Once. So what can you use if you only see the variable one time? Inverses. So can you solve that equation now? Yes, Mr. Kenny. 100%. Thank you. Yes, that's what you sound like in my head because you're being silly. Yeah, it's one variable. We can solve that equation using inverses with properties of equality. That's it. So, here's the thing, Deshaun, could you factor out that 2? 100%. Most students are not super comfortable with it, so I don't sweat it, because you could just set that factor equal to 0, right? The way you would factor it out is both of these have a what in common? So I factor out that 2. 2 times -1 is -2. And I factored a 2 out of here, so I'd be left with an x. I factored the 2 out, and I'd be left with a 2. Okay? I'm going to come back to that in a second. What do I need to do to solve this equation for x? I say there's already minus, so I add. X is equal to 4. Okay. 1, 2, 3, 4. Notice that's also an x-intercept. Boom. Now from there, x equals 4. Don't forget, the reason why x equals 4 is because if I substitute a 4 in, what does it make this?
0.
4 minus 4 is?
0.
The whole idea was we made a 0, right? Okay. Now, here, I want to remind you, read the equation starting with your variable. For instance, when I look at this equation, what's happening to x first? It's being multiplied. Doesn't multiplication happen before addition?
Yes.
You gotta think about your order of operations. X times 2. What happens to 2x? It's being added by 4. What's happening after plus 4?
Equals 0.
So, but is that even an operation?
No.
So the answer is nothing, right? Just plus 4. So what do I need to do? I need to subtract 4. Notice the last thing we just said? That's what I'm undoing. 4 minus 4 makes this a 0. I don't know if y'all picked up on this yet. I know Ms. Kowalski's mentioned it, and I'm going to emphasize it right here. I need you to notice. The order matters. What's the first place I put the minus 4? Was it on the left side or on the right side?
Right.
The left.
Oh, well.
You learn left and right. That's definitely on the left side. Why did I do it on the left side first? I haven't done it to the other side yet. I did it on the left side first for a very specific reason. What's the reason? I needed to make it a 0. Guys, the whole point of inverses is that inverses undo something. I'm not magically choosing to do minus 4. I said, you know what? If I subtract 4, I just made this a 0. And if I make this a 0, what am I left with on the left-hand side? I'm just like, man, 2x is a lot easier than 2x plus 4, isn't it? Okay? But I changed the left-hand side. So I got to change the right-hand side by the same amount. The minus 4 here actually happens before the minus 4 here. That's important because I'm using inverses. That's the starting point. I am undoing crap, and then whatever I do to one side of the equation, I got to do to the other. I subtract 4 on the left side, so I got to subtract 4 on the right side. And it doesn't really matter which side you start on. What matters is, what are you undoing? That's what matters. So what does 2x equal? Okay. Now what do I need to undo? Well, what operation was it?
Divide.
So I need to do multiplication, so I could divide. But I'm not going to divide by 2x, I'm just going to divide by
The reciprocal.
the reciprocal. Well, I'm going to use the reciprocal to divide by 2, right? So half of 2 is 1. So notice, what do I get on the left-hand side here?
X.
Man, that's way easier than dealing with 2x, isn't it? It's even easier than dealing with 2x plus 4. The focus is, I'm trying to get to just that x. So I take half of that negative 4. There's my other root, my other 0, my x-intercept. That's it. So notice, Deshaun, I didn't have to factor it out, but does that agree with what we would get right here if I did factor out that 2? Right? So which one's easier though? Taking the time and effort to factor out that 2 or just setting the factor equal to 0? Yeah, right? So you don't have to sweat that detail. I'm liking the thinking, you just don't need to sweat that detail. Okay? Alright, so we got our roots. What else do we know about this quadratic just looking at it? There's one huge thing we got. Well, we don't have the vertex yet, do we? I'm saying just looking at this function, if I'm trying to graph it, remember, like, We're trying to find roots, but if I'm just looking at
Concave
this
down.
equation, what else do I know?
Concave is down.
It's concave down. We gotta know that that A is negative, that parabola is concave down, okay? But I wanna be more precise with it. What other features can I find of this function right away?
Line of symmetry.
Oh yeah, line of symmetry. Where's that located? In the
Middle.
middle. You can guess and check it, right? Notice if I put my line of symmetry right here, are my roots equidistant? No, right? Where should I probably put it?
1.
Let's check 1. Notice I didn't even have to do any fancy math with that. 3 and 3. That's right in the middle, ain't it? Anyone remember how we could do, I would say, not fancy, but fancy math? Traditional math to find that axis of symmetry? Not sure? Well, we just said it's in the middle, right? Okay. Jane, if I gave you the numbers 17, 31, don't write this down, but 17, 31, 45, 52, how would you find the middle of those numbers? You would find the what? Average. That's it, guys. If you want the middle of something, middle, think average. Average, okay? Notice 4 plus negative 2 divided by 2. What is 2 divided by 2? 1, right? By the way, what is that 1? What's another letter we've used to represent that 1 and what it is? Yes? There's another thing I was thinking about. It's based on one of those forms over there. Because remember, that's the x value of the, so for the v, the vertex. That's the x value of the vertex, right? So it's h. What I just calculated is h. h equals 1. Now, I need y'all to remember this. I'm going to have to erase a little bit just so it's not quite as cluttered. So it's the x value of the vertex. X values are also called what? What's another word? Let me ask you this. If I've got h, how am I going to find k? Tyler, are you awake back there? No, so those are called what? Inputs. Remember, x values are also called inputs. If I want k, there's no fancy formula. I just got to substitute it in. That's it. Right? There's no fancy formula. If I understand that these are called inputs, notice this is language. That's all it is. If you understand the language behind it, it tells you what to do. Don't say I'm not a math person or I'm not a blank person, because you can be. If you understand the language behind it, the language tells you what to do. Because math is a language. There's a lot of procedures involved in the mathematical language, but if you learn the language of mathematics, gosh, it tells you exactly what to do. It's an input. So, f of, what is this x value now? 1. Notice my x is 1. And on this DYU, no, we did not give you a calculator, but we told you we would do the calculations for you if you needed us to. That is a positive 18. So my vertex is 118. Now that creates a problem because this axis only goes up to what?
6.
6. What note did I give you though?
That you could change the y-axis.
You can change the y-axis scale, right? Hey guys, what could I go by to get up to that 18?
3.
3s? Okay. And we'll have you work with another group when we get to some learning stuff later, but jump back to the 8s for now. Alright, so I'm going to go by 3s. I'm not going by 1, 6, 9, 12, 15, 18. Man, I'll tell you what, I have almost every single feature I could even imagine right now. What's the only other feature I could find? There's one more feature that we could find that we haven't looked at yet.
Output.
Huh? Remember, we found our x-intercepts, we found our vertex, we found our line of symmetry. Say it louder. Y-intercepts. Remember the features we want. X-intercepts, Y-intercepts, vertex, line of symmetry. Is that everything? Yeah, that's everything. Oh, and concavity. So, by the way, notice how this is telling us concave down as well?
Yeah.
Okay? I'm not going to be able to go into all these details on the next one because we got to get going with today. But, if I want a y-intercept, what do we know about every y-intercept that's ever existed? Let that x equal 0 then, right? You do those calculations, you come out with a positive 16. So I'm going to have to estimate where it is roughly. How did I get this point? I didn't do any calculations for that. Symmetry. Like the whole point of that line of symmetry is it's the same to both sides, right? There's a pretty darn good looking parabola. And by good looking I mean accurate. Not the best drawing on my part. That's what I get for being on the side. Notice the more points you get, the more accurate your graph becomes. Hitting 5 points pretty accurately like that, it's good stuff. Now, I do want to emphasize and I do want to point this out. This unit, we want you to retain the features of quadratics, and we want you to think through how to find all those features and earn credit on things that you did not earn credit for. You did not earn credit for earlier in the year. So that's why we're getting you to graph these things. But what is the priority of this unit?
To learn.
That's my class. But what's this whole unit about? What does every fair model have involved? What about the quadratics though? Solving quadratics. Do not lose sight of the main goal. We're graphing these features to build our understanding here, get better at these things, so that you can earn proficiency with things you may not have earned in the past. However, this unit's all about solving quadratics. Okay? Is there any part of this previous problem that you need me to leave up for now? No? No? Mm-mm. Okay. I need you to hold on to this. I need us to look at number 2. Looking at number 2, right? Right away, what form do we have that we want to recognize? Because remember, that's the first question that we cannot skip. What form? Vertex form. Alrighty. Now, if I'm trying to graph this, because I am asking you to get there eventually, what point should we be able to immediately see then?
The vertex.
Okay, what is my vertex?
1 and 8. 1 and 18.
118? Huh, that looks familiar. What's my line of symmetry then, by the way?
1.
That's not a line.
Middle.
X equals 1. Remember, 1 is the value, but it's got to be x equals 1. The whole idea is, I'm saying I don't care what the x value is, the x value is always, or what the y value is, the x value is always 1. Man, to get up to this 18, I need again to go by 3's. Okay? So 118. How could I find that y-intercept again? Let x equal 0. So y-intercept x equals 0. So f of 0 equals this. And that's going to be 1. Negative 2 times 1 is negative 2. And what's negative 2 plus 18? 16. All right. So I get this point over here from symmetry. By the way, without doing any work yet, does anyone know what my x-intercepts are going to be? Has anybody figured it out yet? 4 negative 2. How'd you get there?
Same thing we did yesterday with the equations stuff.
But how did you know it was 4 negative 2? We haven't done this one yet.
Yeah, we have. Same before.
What do you mean the same one as before?
This is the same. Line of symmetry and the y-intercept same as the one before.
Oh, the line of symmetry, the vertex, the y-intercept are the same as the one before. So what do you think we might consider numbers 1 and 2? What do we call these two things? There's a mathematical term for that.
Properties of equality.
No. Properties of equality are what you do to one side and you do to the other. To keep the equation something, it does start with an E.
Equal.
Not equal, you're close though. That's what Mason just said. No, remember properties of equality, what you do to one side, you do to the other. To keep the equations this thing though.
Equivalent.
There we go.
Good job,
Guys, does this factored form and this vertex form look exactly the same?
yeah. Oh, no.
Right here as the equations though? Are they giving me the same inputs mapping to the same outputs though? So are they equivalent? Yes, right? Well, I created these intentionally, okay? So these are in fact equivalent. We now need to find our x-intercepts. And so we already are thinking -2 and 4, but we actually need to check ourselves on this. So we're taking this equation, we're setting it equal to 0 because we're looking for x-intercepts. But to find those x-intercepts, what strategy did we identify earlier when we had vertex form? Inverses with properties of equality. All right. Marcus, when I look at this equation right here, what is the very first thing happening to this x?
I'm not gonna lie with you, everything's blurry. I cannot see.
Okay, then come sit up here. Tell me that crap in the future. Come sit in the jack so you can see.
No, like my blood pressure, I just can't see in general.
Okay? Have you gone to the nurse to check in with her?
There's no point. If I leave, I'm gonna just leave school. There's no point. That's why I came here.
There's literally a nurse here to help you to fix this. Okay. Bree, what's happening to x? It's being subtracted by 1. That is what is inside the parentheses. I'm going to work my way around the room. Aiden, what's happening to x minus 1?
It's being subtracted.
We already said the x minus 1.
Oh, you're being squared.
Oh, there we go. X minus 1 is being squared. Zai, do you know what's happening to this x minus 1 squared? Like what's happening after that? Not sure? Jaden, do you know what's happening to x minus 1 squared? Why'd you go with, because I mean there's only two things left, multiplying by -2 and the plus 18. Why'd you go with multiplying by -2? Multiply and divide before you add and subtract, right? That's that order of operations. Parentheses, exponents, multiplication and division, addition and subtraction. So, Zai, what's happening after we multiply by -2? Adding 18, right? So what is the outermost layer of my onion? The 18, right? What do I need to undo? So 18. Notice, what am I going to do to undo that 18?
Subtract.
So which side do I actually subtract from first?
The right.
I subtract from the right. 18 minus 18.
0.
0. I peeled away the outermost layer of that onion. Now thinking back to what we just discussed, what's my outermost layer at this point? What about that -2? It's being multiplied, so I need to divide or I need to use that reciprocal. So remember, you can just do the traditional division here. Does anyone know? So first off, what's a negative divided by a negative? Positive, okay. 18 divided by 2? 9. Okay? Now, I want to pause for a second. I want to show something that I think, Lane, you asked me something. I told you yesterday, don't do this, right? Yes, okay. So, what Lane started to do yesterday, so putting a pause on that for a second, Lane, what you started to do is you distributed this -2, right?
Yeah.
And that ended up leading to something that, well, I'm not going to focus on, but I need y'all to hear me on this. You cannot distribute the -2 right here. Anyone know why? Why can you not distribute that -2?
Because it's not the way you want it to be.
It mathematically does not work. There's a reason.
It's squared.
What about the square?
It's the 2
The 2, the -2, is that being squared?
squared.
No, just the x minus 1, right?
Yes,
You, it's different. You got to do exponents before you can multiply. Really, what it means to square something is this. And you can only distribute this to 1, but if you distribute it inside of the square, you're multiplying that -2 twice. We're not multiplying -2 twice, we're multiplying -2 once. do not distribute. If you have vertex form, don't make your life hard, just use inverses with properties of equality. Now, the question I think is going to end up answering almost everybody's question at this point is what to do here. So when I have x minus 1 squared, what's the inverse of that point? Square root, right? All you have to do is recognize, hey, I got a square, I need to undo that square, I got to take a square root. Cool. Now, right here, I need you to remember, the whole idea is that a square root and the square are what? The whole point of vertex form, they're called inverses. So what do? They undo each other. Technically, what it's making is an exponent of 1. Notice how we've always made zeros and ones so far? It's making an exponent of 1 is what that square root's doing. And then, what I did on the right-hand side, and I do it on the left. What's that called again?
Well, probably is.
Remember, the square root was the inverse. Doing it to both sides, property of equality. Okay? So what am I left with on the left-hand side? Alright, so the square root of 9. 3, right? 3 times 3 is 9, okay? So 3 is equal to, what's on the right-hand side? X minus 1. Now, I need to pause, I need to ask, is 3 times 3 the only way to get 9? No, what other way can do it? A negative, right? Both a positive and a negative. Remember how Ms. Kowalski talked about this? Guys, for the most part, if you're not graphing, you're going to be able to have a calculator. You just type in the square root of 9 in the calculator, but you have to remember, because the calculator can't do it for you, you have to remember that it's both a positive and a negative. A positive and a negative. You've got to have both. Okay? Now, I want to pause and I want to point this out. We started all the way back here with this equation, didn't we? Now we've gotten down to this. That's way easier, isn't it? But this way easier one is not helpful unless it's telling the same story as the original. Is this equation telling the same story as this one up here? Aiden says no, why not? Not sure? Not confident?
I think that,
How would we know? Don't know? Okay, let's do this. All right, let's finish this out. What am I going to finish doing to solve for x? Add 1, thank you. All right, so what is positive 3 plus 1? What was it? 4. What's negative 3 plus 1? Negative 2. Well, first off, are those the same roots we saw earlier? 100%, right? All right. Do y'all remember what it means to be a solution to solve an equation? So like, getting away from the graphing side of things, what does it mean to solve? Oh, I'll put this back up in a second. If y'all can just pause, I'll let y'all write this down in a second. What does it mean to solve? Not sure? I need everybody to go grab a calculator for me. Each person in class needs a calculator, which apparently a lot of my stats kids have one. So if you have to share one with somebody, you can do that. It'll be close to if we have enough. Okay. Alright, so I need you to create a calculator page. Okay? Now, what I need everybody to do is I need you to type out the original expression. I believe, was it negative 2? So you want to hit the negative underneath the 3. Be careful and make sure you hit the negative underneath the 3. Negative 2, parentheses, what was it, x minus 1, parentheses, nope, that's not what I wanted. Parentheses, squared, plus 18. Okay. If you do not have that typed out like this, ask somebody for help. Make sure that you know how to type that expression in. Are you gonna be able to do it? You're not blood pressure, then put it in and type out this. There you go. There you go. All right. So, what we got down to was that x equals what again? What did x end up equaling? 4 to negative 2, okay? So, first off, that complicated thing is what we started with, right? And we started with it equaling what? So notice you can hit equals right next to the trig and then say equal to 0. We got that all the way down to saying that x equals 2, or negative 2, and x equals 4. I need y'all to hear, my question is this equation and this equation telling the same story? How do you know? I'm not trying to graph yet, because I'll point this out. Do I have inputs and outputs in this equation?
It's giving the same inputs.
But do we have inputs and outputs here? No, we only have one variable. Okay, so let's do this really quickly. In the place of where this x is, right here. So go to the center of that. In the place of x, put negative 2. Type that in for me, and then hit enter. It says what? It says true. Wait, so if I take that x equals negative 2 and I substitute it in, that equation tells me true. Interesting. I want you to scroll up, so hit the up arrow until that equation is in blue. Hit enter. And put 4 in the place of that negative 2. So it should look like this now. Any guesses what that's going to tell us? True, maybe? Interesting. I want each of you to do this 3 more times. Pick any numbers that you can think of. Put them in for x and see what it tells you. I don't care what numbers you pick. I need you to just type in some numbers. Test it out. So remember, just trying to make your life a little bit easier. Scroll up, hit enter. And remember, the whole idea is that it's supposed to equal 0. And we tested a negative 2. It says true. We tested 4. And it says true. Now I want you to type anything in the place of that x to see if it'll make that equation true.
Have a positive number?
Any number in the world. It could be a decimal, it could be a fraction, it could be imaginary, it could be positive, negative. Huh? Oh, try a few more. Guys, remember I said any number in the world. Type it in, test it out. So remember, it does equal 0, but what I was showing you earlier is if you type it equal to 0 and hit enter, it'll say true. Try typing some more numbers in. Okay. Has anybody found a number besides negative 2 and 4 that makes that equation true? No. Because what we did is we solved the equation. What do solutions do to an equation? They make the equation true. That's it. When you are asked, hey, solve this equation, hey, find what makes that equation true. Notice this algebraic process, like, could you continue guessing and checking for the rest of your life? Yes. Do you want to?
No.
Hard no. I don't want to spend more than 2 minutes trying to solve this equation. So that's why we developed algebra, to make our job easier. Like, solution just makes that equation true, but like, if I could just solve it, man, that makes my life way easier. Okay? Say again.
I kept getting false.
Yeah, because you know the only values that make that equation true?
2 and 4.
2, well, negative 2 and positive 4. So, if you weren't aware of this, please write down this definition. Solution. What do solutions do? They make the equation. Do you think it only is equations? So expressions you can't make true, but there is another one. There's expressions, equations, and inequalities. X is greater than 4, 3x plus 7 is less than 8. It's all about making it true. So when you are asked to solve, what does that mean to solve? Find the, yeah, so find what makes the equation true, so find the solutions. I would imagine most of us have had teachers tell us to solve every single problem they have ever asked you to deal with. Haven't they, you pretty much seen the word solve every single time you do something in math? Yep. But if I'm trying to graph a function, that's not solving. If I'm trying to identify the features of a function, I'm not solving. Solving only means find the solutions. So hold on to that, okay? Yeah. And we have these techniques that are available to us to help us solve. Here's this if you still need some more. But I need to make sure we clearly understand what solving actually means. Because what we have determines how we solve it. If I have factored form, I'm trying to use a zero product property. If I have vertex form, I'm trying to use inverses with properties of equality. And if I have standard form, I'm not about that life. I do something else. Okay? Last thing quickly for those of us who are trying to do this, I'm just going to look at this one briefly. I need y'all to remember and note, we have a quadratic function here. We're trying to write the equation. Which form would be the easiest for this quadratic function? Factored form? Why factored form?
Because you're gonna get 2 points.
Because I already got which 2 points? I got the x-intercepts, right? I've got -4 and I've got 6. So, f of x equals a times x minus r1 times x minus r2. I already have my roots. X plus 4, x minus 6. Remember, I have to have the opposite. And then the last thing that someone asked around the room is, how do you find the a value, right? Or what is the equation to get a? There is no equation to get a. The reality is you just have to have a point. If I have, I'm going to look at it, I think it's going by 2, so 32, 34, 36, and 40. Okay? I can use any point in the world, but that's this y-intercept is the easiest one that I see. So if I have an input of 0, what does that map to? What output?
0.
What's the y-intercept, but what is my y-intercept all the way up here? 36. So an input of 0 maps to 36. That's my output. So 36, my output, is equal to a times my x of 0 plus 4, my x of 0 minus 6. No, she's at a job interview in New Jersey. She'll be flying back tonight. She'll be here tomorrow. She has 2 interviews today, actually. No.
I'm guessing she passed her classes.
So I mean, she still has to officially pass, and she'll find out about her EdTPA stuff on Thursday, I believe. But I mean, she still has to start applying for jobs before everything's official. Yeah. All right. But notice there's not an equation. It's just substituting into the equation that you already have. What is 0 plus 4?
4.
0 to minus 6.
-6.
So I've got negative 24 times a. Oh, and look, how many times do I have an unknown in this equation? So what am I going to use? Now, what am I going to use if I only have my unknown once?
Inverse. Inverse is inverse.
Thank you, thank you, thank you. If I only have my unknown one time,
Oh.
I can use inverses with properties of equality. Yes. See how there's a pattern here? See, this is why I love math. Because it's not a new thing every single time. It's a pattern that we can discover and make sense of. And when we learn our patterns in our relationships, when we learn the terminology, the whole world becomes a lot easier to tackle. It does. The world of math, the world outside of math. Again, just to show it, if you want to divide by negative 24 in that traditional way, rather than use the reciprocal, you can. I would have done this math for you. A just comes out to be negative 3/2. So your function in this one, negative 3/2 times x plus 4 times x minus 6.
And couldn't we use that to figure out standard,
You could. I wouldn't.
using it or with a vertex?
You can figure out the vertex form too. I wouldn't. You're 100%, you can. But it does say just create an equation. So if you've got factored form, you're done. If you want to make vertex form as well, hey, that gets you to that CCC plus. If you want to convert that to standard form, you can. That was not what was asked. All right. Whew, I spent way longer on that than I meant to. All right, I'm going to do two things with this very quickly before we go into the last method to solve a quadratic equation. Nope. Well, yes, it's going to be this, but we'll get there in a second. So you can hold on to your demonstrated understanding, learn from it, grow from it. Let's do better next time. Now, what was the only form of a quadratic we don't want to solve in? Standard form, right? So, if I gave you I'll have to think for a second, hold on. There we go. If I gave you this equation right here, right? It's in standard form. What could I do? Someone asked about this. More detail on the conversion. So I could try to use the area model to help me go to what form? I could use area model to help me go to factored form, right? I definitely actually don't want to do that right now. I need y'all to look at again why. So notice I just made up an example here. It's not something you have. I would not factor this yet. Because of that 3, yeah. So remember, the whole point of factored form is to use the zero product property. I need y'all to hear me on that again. The whole point of factored form is to use the zero product property. Well, if it's not equal to 0, can I use the zero product property? No. Now, I'm going to show you something actually in this case. This is one of those cases where I definitively, personally, would not use the vertex form. Okay, so I'm going to come back to the area model in a second. But can anyone see why I would not want to use the vertex form here? No idea? What would be my first step in using vertex form? What's the first thing I need for converting to vertex form? Well, I'm going to go out and give you a hint. Okay, Taj, if I want vertex form, what do I need? I need the vertex, thank you, right? I need the vertex, okay. Well, so what would I need to do to find the vertex from standard form? H is equal to.
How you need inputs and outputs? So H and K.
Well, I need H and K, right? So what is H equal to, though? Divided by 2a. So the opposite of negative 3 is 3. 2 times 2 is 4. Do you now see why I would not want to use vertex form?
Yeah.
Why?
That's the way. You don't even know how to use it.
Well, I don't have it. I mean, I can find it. I just found my H, but what about that H is saying, nah, I don't want to.
It's decimal to decimal.
So it's a fraction, or I can convert it to a decimal. Do you want to do that?
No.
No. Okay, cool. that's okay. I would personally, I could, but I don't want to convert this vertex form. But if I look at this one for my factoring, and so I'm only doing this quickly to get into what we're doing today for the last half hour class. What do I know for this area model already? Do I know this box?
Yeah. X squared.
Not x squared, 2x squared. Yep, my quadratic term. And then the bottom one is, yep, that positive 9.
I'm looking at that above.
Still got to find these to go right here. So I need factors of 9 that add up to negative 3. Are there factors of 9 that add up to negative 3? Positive 3 and negative 3? Those are factors of negative 9, they add up to 0.
Negative,
So here's what I'll remind you, it is not 9 here. Remember,
12.
You said it has like multiply together to get 9, never mind.
it's not 9. There are no factors of 9 that add up to negative 3. What is A? 2. What's C? So what does that give me? Are there, although
Serious, huh?
hold on. I actually screwed this one up that I was planning on doing in the first place. That's what I should have. Okay. So, are there factors of 18 that could add up to, now I made it 9. What are they? Factors of 18 that add up to that 9.
Positive 2, positive 9.
Those add up to 9?
My fault.
Those are factors of 18, but they don't add up to 9.
1 and 9.
3 and 6.
I'll say 1 and 9 are not even factors of 18. You can do 1 and 18, but do those work? No. Lane, you said 3 and
6.
do those add up to 9? So notice, now I can factor it, okay? But do notice, it has to be A times C. If it's a 1 in front, you don't have to sweat it, okay? But then, sometimes, you get something like this. I'm going to make my job a little bit easier. There we go. Yep, okay. In this case, in this case, it would be 1 times negative 20. Are there factors of negative 20 that add up to negative 6? So let's start at the basics. So 1 and negative 20, 2 and negative 10, 4 and negative 5. Do any of those add up to negative 6?
No.
No. So can I even factor this one? Can't do it, okay? Can't factor it. But H, right? So there are no factors of A times C that add up to B. H equals the opposite of B divided by 2A. What's the opposite of negative 6?
6.
Divided by 2 times 1, which is 6 divided by 2, or 3. That's easy, isn't it? Then I find K. So K is equal to, and if I do all of that work, and by I mean calculator, I get negative 29. So then I just substitute into my vertex equation. A is 1, x minus 3, x minus h squared, plus k, so minus 29. Then I solve that equation. Okay? But what if I get something like I actually had earlier when I screwed up? Because when I screwed up earlier, one, we said h was 3/4, and that was ugly. We didn't want to use vertex form, right? If you do 2 times 9, you get 18, and there are no factors of a positive 18 that add up to negative 3. So can I factor it? So what do you do in that case? Huh? Say it louder. You could still do it. I do want you to hear me clearly on this. Converting to vertex form does always work. But dealing with a fraction is something most students don't want to do. So that's why we have this task. I don't think y'all got this yesterday. Third block got there, but not y'all. So how do we find some zeros? Clearly we got to get some vertical surfaces. I've already put Mason and Samija to sleep.
Zero product property.
What?
You said how we find zero.
Well, you can only find zeros using zero product property in what form?
Factor.
And only when that factored form is equal to.
Zero.
But what if we don't have factored form? Remember, the process of going to vertex form is also a process for finding zeros. Okay? But what if we can't use vertex form and we can't use factored form? We're just up a creek, right? No, we got strategies. Strategies on strategies on strategies. And can you hand this to Aiden? Alright, so looking at this. Actually, I want you all to go to your vertical surfaces and draw this out. Now I'm going to clarify and make sure we all understand what's happening here. We have what type of function? Looking at the directions, guys, what type of function do we have?
Vertex.
That's not a type of function.
Parabola.
That's a quadratic. Remember, vertex is a part of a parabola, a quadratic function, okay? And so what do we know about this quadratic? It has a vertex of 2, negative 5. And we know an x-intercept, right? I need you to use those features to sketch out what we already have and then find the other x-intercepts. Because how many x-intercepts do parabolas normally have? 2. I need you to find the other one. Work with your small group on drawing this out, making sense out of this. Just a couple minutes. So, no. I've got it zoomed in. I need y'all coming up in this region here to be close and on the action, just leaving space so that you're not in the camera. Yep, sir. Yep.
1,056,000.
Okay, yeah. Give me that number again. What did I originally give y'all?
The distance from 237 to 1,057,184.
1,057,184. Okay, so I need y'all to pay attention to this question that I asked the aces. I asked the aces, how would you find the distance from 237 to 1,057,184? I'm going to have them answer in a second, but I want to see what y'all think. How would I find that distance? Subtract? Is that what you did? Notice, if I take this number and I subtract where I started, does that tell me how far apart they are? When you hear the word distance in mathematics, you should think of the word difference. How far apart are they, and what operation goes with the difference? Subtraction. So, I need y'all to look at this. We said earlier, with those nice easy numbers, that the distance on one side, we had to go to the other, correct? Personally, I'm going to draw my line of symmetry in here. And what I need to know is, how far is it from -4 to -1.764? How do I determine how far apart those are? How do I find that distance? I just subtract them. So, minus, now you have to be careful here, -4. Please pick up a calculator, right? And I need that distance. What is it?
2.263.
2.236.
36.
Notice a distance is subtraction. Right, Deshaun? What is that? Is?
That is equal to that.
Distance is subtraction. Distance is a difference
That's what you
between those numbers, okay? So, how would I now find the other x coordinate? Notice we added to go this way, and so to go the other way, we're going to subtract 2.236. Okay? So, I need us to grab a seat and make sure we have this information down so that we are able to get set up. Now pause, I need to reemphasize this. How are we going to find this distance here? We have to do a difference, okay? Distance is a difference, it is subtraction. And then to find the other point, hey, by the way, does anyone know what else I could call this point right here besides just an x-intercept? Some other words I could use?
Root.
I could call it a root, or I could call it a
Zero.
zero, right? So to find the other root, subtract. What are we subtracting? Yeah, but what is that? That's the distance. Subtract the distance
I was listening.
from the line of symmetry. So that's our big idea. It's just understanding symmetry. When you understand symmetry, you understand how to find that distance, and be good to go. So what's the question again? If I give you an equation, what are we going to have to now find out how to do? Well, I mean, hopefully you know how to subtract the distance, but if I give you the equation, what are you going to have to be able to find? The distance. Because I will point this out. If you have h and you have your distance, how do you get the rightmost one? You just add the distance. How do you get the leftmost one? You subtract the distance, right? So once you have h, you just got to add and subtract that distance. That's easy. The question is, how do we find that distance? Right? If you're given a graph, it's easy to find that distance. If you're not given a graph, it's actually still easy to find that distance. We just don't know how to do it yet. We need to understand that distance is a difference. Now, there's some great notes there, Deshaun. I did it. Dog, we are 87 minutes out of 90 minutes into class. They gave you a freaking pencil ages ago. Good catch.
That's fine.
All right. So what are we going to be working on tomorrow? Yeah, but what is this? What is the thing I'm leaving us on? What do we got to learn how to do? We got to learn how to find that distance. Guys, if you have not done the check your understanding for factored form, for vertex form, for solving in standard form when you can factor, for solving in standard form when you can write the vertex form, you need to do that. This stuff does not magically pop in your head. Hard work pays off. In my AP Stats class, I do not make homework mandatory, just like I don't make it mandatory in here. However, there are 3 students who have either a 98 or a 100 in that class. One of them, he's a freak of nature. I love the kid. He doesn't do a single lick of homework. The other 2 have 98s and 100s. They do all the homework all the time. You know why they have 98s and 100s? Because they work their tails off. This stuff doesn't magically pop into anybody's head. It takes time and effort and dedication. You've got to do some practice. You've got to make the time and effort. You can, You gotta take the time to do some check your understanding. When you start doing the check your understanding, looking over your notes, it makes a difference and you start to learn stuff. I need you doing your assignments